Have you ever wondered if that ancient manuscript in the museum is the real deal or a clever fake? For centuries, forgers have duped historians with impeccable imitations. But now, machine learning is changing the game, spotting inconsistencies that human eyes miss. This technology analyzes everything from ink composition to handwriting quirks, revealing truths hidden in plain sight. Join us as we dive into how AI is unmasking historical deceptions, starting with the basics of forgery detection. Forgery in historical documents isn't just about copying text. It's an art of deception involving materials, styles, and even aging techniques. Think of the Hitler diaries, which fooled experts in the 1980s with fabricated entries. Machine learning steps in by training on vast datasets of authentic writings, learning subtle patterns in language use and syntax that forgers often overlook. This allows it to flag deviations with high accuracy, turning guesswork into precise science. One key method involves spectral imaging, where ML algorithms process multispectral scans to detect ink variations invisible to the naked eye. For instance, in the Vinland map, once thought to prove Vikings reached America before Columbus, ML revealed anachronistic titanium-based ink. By comparing pixel intensities across wavelengths, these models can differentiate modern pigments from historical ones, providing irrefutable evidence of tampering or outright fabrication in priceless artifacts. Handwriting analysis takes a leap forward with ML. Traditional experts rely on intuition, but algorithms quantify stroke pressure, angle, and speed from digitized samples. In cases like the forged Galileo letter, ML compared it against verified works, spotting unnatural hesitations indicative of copying. This quantitative approach builds probabilistic models, estimating the likelihood of authenticity based on thousands of features, far beyond human capability in consistency and detail. Linguistic forensics is another frontier. ML models trained on era-specific texts can detect anachronistic words or phrases. For the Archimedes palimpsest, while not a forgery, similar tech helped recover underlying text. In fakes, it identifies modern idioms slipping into supposed ancient prose. By vectorizing language into high-dimensional spaces, these systems compute semantic distances, flagging content that doesn't align with historical linguistic evolution. Paper and parchment analysis uses ML to examine fiber structures and degradation patterns. Forgers might use old paper, but ML spots artificial aging like chemical treatments. In the case of fake Dead Sea Scroll fragments, imaging revealed inconsistent wear. Algorithms classify microstructures from microscope scans, building classifiers that distinguish natural antiquity from lab-induced patina, ensuring museums don't harbor sophisticated counterfeits. Dating techniques integrate with ML for carbon analysis, but beyond that, stylistic evolution in art and script is modeled. For illuminated manuscripts, ML detects inconsistencies in pigment use or iconography. The forged Gospel of Barnabas was exposed partly through such methods, as algorithms compared it to contemporaneous works, revealing stylistic anomalies that betrayed its modern origin despite clever mimicry. Provenance tracking benefits from ML by cross-referencing auction records and ownership histories with pattern recognition. Fakes often have fabricated backstories, but ML uncovers inconsistencies in documentation. In the art world, this has exposed rings of forgers, like those behind fake antiquities. By mining databases, these systems predict forgery hotspots, alerting curators to suspicious pieces before they enter collections. Deep learning excels in image restoration and enhancement, indirectly aiding forgery detection by clarifying details. For blurred or damaged texts, convolutional neural networks reconstruct missing parts, then compare to known forgeries. This was pivotal in analyzing the protocols of the Elders of Zion, a notorious fake, where ML enhanced scans to reveal typewriter artifacts inconsistent with its claimed era. Collaborative datasets are crucial. Institutions share scanned documents to train robust ML models. This crowdsourced approach improves accuracy across cultures and epochs. For Asian manuscripts, like forged Tang Dynasty poems, ML adapts to calligraphic nuances, detecting pressure variations in brushstrokes that forgers can't perfectly replicate. Such global cooperation is key to staying ahead of evolving forgery techniques. Challenges remain. ML isn't infallible and requires high-quality training data to avoid biases. Overfitting to specific forgeries can miss novel ones. In the Jefferson Davis letter forgery, initial ML scans missed contextual clues that historians caught. Balancing AI with human expertise ensures comprehensive analysis, where machines handle data crunching and experts interpret cultural subtleties. Ethical considerations arise. What if ML wrongly accuses a genuine artifact? False positives could damage reputations or devalue items. Rigorous validation protocols are essential, involving multiple models and peer reviews. In the art market, this tech levels the playing field, deterring forgers and protecting buyers from multi-million-dollar scams involving historical documents. Future advancements promise even finer detection, like nanoscale material analysis integrated with ML. Quantum computing could process vast datasets instantaneously, uncovering forgeries in real-time auctions. For underwater artifacts, like those from shipwrecks, ML could analyze corrosion patterns to verify authenticity, expanding its reach beyond dryland documents to submerged histories. Case study: the forged Shakespeare folios. EML dissected linguistic patterns, finding word frequencies mismatched with Elizabethan English. By employing natural language processing, it quantified iambic pentameter deviations and archaic spellings, proving the documents were Victorian inventions. This not only exposed the fake, but enriched our understanding of authentic bard style through comparative data. In musicology, ML detects forgeries in composers' scores by analyzing harmonic progressions and notation styles. For historical treaties, it verifies signatures through biomechanical models of hand movements. The Treaty of Versailles had rumored fakes, but ML could confirm originals by modeling ink diffusion over time, a technique adaptable to any inked document. Art historians use ML for provenance in paintings, but for documents, it's about chain of custody. Forged Lincoln letters have been caught by tracing paper sources via isotopic analysis fed into ML classifiers. This geochemical approach, combined with digital forensics, creates a multifaceted shield against deception in archival collections. ML's role in debunking conspiracy theories is notable, for example, analyzing the moon landing documents for authenticity. While not forgeries, similar tech exposes faked evidence in historical debates. By quantifying document integrity, it promotes factual discourse, countering misinformation with data-driven insights into our past. Training ML on diverse scripts, from cuneiform to hieroglyphs, broadens its applicability. For Mesopotamian tablets, it detects chisel marks inconsistent with ancient tools. This preserves cultural heritage by identifying looted or faked artifacts, aiding repatriation efforts and enriching global museums with verified pieces. Integration with blockchain for digital provenance ensures tamper-proof records of authenticity checks. For rare books, ML scans combined with NFT-like certificates prevent future forgeries. This tech fusion safeguards literary treasures like first-edition novels from counterfeit markets that undermine collectors' investments. Adversarial ML tests forgery detection by generating synthetic fakes to train against. This cat-and-mouse game improves robustness, as seen in evolving art forgeries. For historical maps, it spots redrawn boundaries or added features that alter geopolitical narratives, preserving accurate historical records. Public engagement through apps allows amateurs to scan documents for preliminary checks, democratizing expertise. While not replacing professionals, it educates on forgery signs, like in family heirlooms. ML empowers individuals to question and verify, fostering a culture of informed skepticism towards historical claims. Interdisciplinary collaboration between computer scientists and historians refines ML models. Feedback loops from real-world applications, like the forged Mussolini diaries, enhance algorithms. This synergy uncovers nuanced forgeries, blending tech precision with humanistic insight for a fuller picture of history. ML's predictive power forecasts forgery trends based on market demands, preempting waves of fakes in hot areas like Civil War memorabilia. By analyzing sales data, it identifies patterns, helping authorities intercept counterfeit operations before they flood the market with deceptive history. In literature, ML detects plagiarized or forged attributions like spurious Chaucer tales. It parses narrative structures and vocabulary to match authorial fingerprints, safeguarding literary canons from dilution by inauthentic works that mislead scholars and readers alike. For religious texts, sensitivity is key. ML exposes fakes without bias, like in apocryphal Gospels. It analyzes textual variance against canonical versions, revealing interpolations that alter doctrines, thus aiding theologians in discerning original teachings from later inventions. Global impact. In non-Western contexts, ML adapts to scripts like Arabic or Sanskrit, exposing forgeries in colonial-era documents that skewed histories. This decolonizes narratives by verifying indigenous records, empowering marginalized voices through technological equity in historical validation. Wrapping up, machine learning isn't just a tool, it's a guardian of truth in historical scholarship. By continually evolving, it ensures that our understanding of the past remains untainted by deception, inviting deeper explorations into the authentic stories that shape our world today.